Okay, so in this topic, we are learning to calculate mean and standard deviation from data so that we can be using the mean and standard deviation for some interpretation. Okay, for the calculation, we will divide into two sets of data. There are two kinds of data. There are ungrouped data. So in other words, right, ungrouped data are single data. Okay, and group data, in a way, you can just see it as the data in a table. So group data means they already put the data into tables. So that one is called group data. So in your lower set, you already calculate the mean. So you kind of add up all the values and then you divide by the number of data. Okay, so in lower set, you also learn how to calculate the mean from the table. Okay, but you don't really see this formula. Okay, you just know the calculation, but you don't really see this formula. So later on, I'll talk more about the formula. And obviously, you also didn't see this notation. Okay, so I will be going through the basic notation in a while time. Before that, okay, let me introduce the idea of standard deviation first. So we are using standard deviation to calculate the spread of the data. Spread of the data from the mean. That means how far it actually deviates from the mean. So if there's a lot of deviation from the mean, right, it's actually not so good. Okay, so if you look at the relation here, the higher the standard deviation, okay, the more spread is the data. So in another word, if standard deviation is very high, there's a lot of deviation, so there will be a lot of deviation from the mean. So a lot of deviation from the mean, right, means that it's actually not consistent. Okay, so it's a way to measure how consistent you are. Okay, so I think it's easier if I give you a context. So if let's say there are two students, student A and student B. So this will be the test result for the student A. So student A will be like 64, 68, and 61. Another student can be something like 90, 50, and then 60. Okay, so if you look at student A and student B, okay, without doing any calculation, I will just tell you that student B actually got more deviation. So if you look at the student B result, sometimes he can get very high, sometimes he can just pass. So I will say, right, student B is not so consistent. So if I really go and calculate the standard deviation between student A and student B, I expect student B to have higher standard deviation. Okay, so anyway, that is just a generic idea first. We'll talk more about that later on. For the standard deviation, we also have single data, and we also have table data. So there will be two big formula that you actually need to know. The one for the table data is provided in the O level. So it's provided in the O level. So if it's actually provided in the O level, right, sometimes we will modify this to get the single data. So how to modify, right? We remove all the F. So if you look, you remove the F and you change this to the number of data. Okay, so you can actually modify from the given formula so that you don't have to memorize. So anyway, what are the weird symbol, right? Okay, so let's introduce a symbol first, then I'll show you numerical example. How do you calculate based on the data? So N essentially will represent the number of data. Okay, and this one is known as summation of X. So in a way, this is called the sum of x. Means, right, you're going to add up all the x. Okay, and then this one will be the sum of x squared. So the symbol is to tell you that you are adding up sum of x squared, meaning, right, you will square individual value, then you add them up. Okay, and then this one is called the sum of f, which means, right, you add up all the frequency. Okay, then these two will be the two that a lot of people will get confused. So this one represents the sum of fx. So meaning you multiply f and x, and then you add them up. So you multiply the f and x, and then you add them up. Anyway, later on, I will show you all this in numerical format. Okay, then this one will be the sum of fx squared. The square is on the x. So it's something like f1 times x1 squared. You square the x, you don't square the f. f2 times x2 squared. Okay, f3 times x3 squared. And then you keep adding up. So anyway, this one, you just understand that you are summing up something. What are you summing up? Okay, it depends on what the notation follow. So sum of x. Okay, this one is like sum of x. This is sum of x squared. So this is sum of f. Okay, so just understand the symbol. I will show you numerical value. So remember, at this point, right, you need to understand that there are single data and there are table data. Single or table data. So single data, we will use the method for single data to calculate mean and standard deviation. For group data, we'll use another formula, the O-level formula. Okay, so anyway, I'll be showing you the cases. It will be clearer if I show you the numerical example. So in this case, okay, this is called single data. Example 1 is purely single data. So in a way, these are all the x. So you can see like x1, x2, x3. Okay. If you are calculating just on the mean and standard deviation, you do not need to arrange. If you are calculating median, then yes, you need to arrange from the smallest to the biggest. So right now, you do not need to. Okay. So this is a single data. I'm going to be using these two formula. Okay, and look at what the formula require. The formula require n, which is the number of data. So you can count the number of data. So there are 8 data here. Okay, then you will, so if you look at the formula, you will need these 3 items. So I will need the sum of x. Sum of x means literally I add up all my x. So I will add up all my x. So in this case, you will get a 70. Okay, the other one will be sum of x squared. So if you still remember just now, so your job is to square every x. So every x that I gotten here, I'm going to be squaring first. I square and I add them up. So this, you will expect this to be a bigger number because you are squaring before you add them up. So it's quite expected that you will get a huge number. So I get 676. Okay, so if you want to be a bit organized, you can write out the information first. So you got the 3 items to insert into the formula. These 3 items, right, can also be obtained from the statistical mode in your calculator. So when if you're gonna use the statistical mode in your calculator, right? There's another way of pressing. So I will not be showing you because different calculator actually got different way of input the data. So I'm showing the manual calculation. That means you can do this calculation across any calculator. So once you got the three items, okay, so I can just try to insert into the formula. It will be a good habit if you write the formula first. So you are adding up all the x and then you divide by 8. So you'll be good if you write the formula first. So the mean is 8.75. Okay, the standard deviation looks a little bit bigger. Okay, so be careful first. Okay, this is the sum of x squared, which is 676. Then the sum of x will be 70. So basically, I'm just inserting these three items into the formula. It's really as simple as you just insert and then you punch calculator. Usually the standard deviation won't be a nice number, so you return it as a 3SF. So that is how you calculate a mean and standard deviation from single data. Okay, so single data, you need the three items, and then you can plug into the formula for mean and standard deviation. Okay, the second example shows group data. Group data are table data. So there are two kinds of table data. Okay, so before we do any interpretation, make sure you read the instruction first. So in this question, the table shows the numbers of hours by 20 students to complete a jigsaw puzzle. So you must have an idea of interpretation first. So here there are two students who take 1 hour each. And here I got 6 students who take 2 hours each. Okay, so you must be able to do this kind of interpretation. So in the lower side, right, if you're going to calculate the mean, you actually add up. You actually multiply first, because when you multiply, you get the hours by the 2 students. When you multiply, you get 12 hours. So in fact, too, when you do the calculation, you get the total number of hours divided by the total number of students, which is exactly the same as this formula. So where is the x and the f in this formula? So x is the number of hours. F is the frequency. So in our situation, right, the number of students is the frequency. So when you are looking at a table data, you must be able to tell which one is the x, which one is f. F is the counting. So in this sense, right, the total should add up to, the total frequency will add up to 20. Okay, that means the sum of the f, in this case, right, will add up to 20. Because the context is meant for 20 students. Okay, so let's try to find if you look at the formula for the two formula, you will need three items. You will need sum of f, you will need sum of fx, you will also need sum of fx squared. So I got to have the three items. Currently, to me, the obvious one is sum of f because there are 20 students. Sum of fx squared, okay, I don't know yet, so I got to calculate. So how do you calculate? It's f times x squared. So you are squaring the x. Then you multiply. So it's like 2 times 1 squared. 6 times 2 squared. 8 times 3 squared. 3 times 4 squared. 1 times 5 squared. So I square the x and then I multiply. So that is the meaning of fx squared. So again, you will expect this number to be quite huge. So I'm getting a 171. Okay, I already worked it out. Sum of fx means, right, you don't need to square the x. You do a direct multiplication. So when you do a direct multiplication, it will be something like 2 times 1, 6 times 2, 8 times 3, 3 times 4, and then 1 times 5. So essentially, you're getting the total hours taken by the 20 students. So you get 55. So if you look at what you are multiplying, you are getting the total hours taken by the 20 students. Okay, so right now I got the 3 items. I can just try to input the 3 items into the formula. If you are thinking, right, do you need to show the working or not, right? You actually don't need to show the working. The working is not necessary. I just need to get the 171. I just need to see the 55. I don't need you to do the working. But if you're very careless that you'll make, if you're worried that you'll make careless mistakes, then I suggest you write it up. Okay, so I will always suggest that you have the 3 items, then you input into the formula. Okay, why do I say so? Some students, right, they directly input into the 3 formula. So they make the formula very complex. So you calculate individual item first. So once you get the 3 items, then you input into the formula. So the sum of fx is actually the total hours. The sum of f is actually the total students. So in this case, the total hour is 55, and then I got 20 students. So on average, they take something like 2.75 hours. Okay, here come the standard deviation. So I'm getting the biggest item here first. Sum of fx squared, which is 171, divided by the number of students. So this part is actually the mean. Okay, if you realize this part is actually the mean, which is like 55 over 20 squared. And then you just punch calculator. So usually, again, you're not getting a very nice answer. So it will be 0.994 hours, 3 FM. So how do you make out of the standard deviation? Okay, so again, standard deviation is the deviation from the mean. So you might want to think of it like, generally a person will spend around 2.75 hours plus minus 0.994. So I'm expecting people to spend around this amount of time. So maybe another person, I'm expecting another person to be like 0.994 added to the 2.75 hours. Or a person can be like 2.75 minus 0.994 hours. So that is the deviation, how much you deviate from the mean. Okay, so that is the calculation. So just now when I start this example, I mentioned that for the table data, there are 2 types. So this type is the accurate table data. Accurate because I can tell like 2 students take 1 hour each, 6 students takes 2 hours each. The next one is the not accurate table data. It is also a table data, but it's not so accurate. Okay, and because it's not so accurate, it is only an estimated. Okay, so in this table, we are showing the length of 30 leaves. So if you look at the interpretation, so I got 3 leaves. There are 3 leaves here. The length is between 0 to 4 centimeter. So for these 3 leaves, right, I don't know their actual length. Maybe like this one is 1.5 centimeter. This one is 2.5 centimeter. and then another one that is like maybe 2 centimeter. So this table is not accurate because I do not have the actual value of each of the leaf. So for example, these 3 leaves, they can look like this. So I do not know the actual one. So we are going to use the mid value. So in this case, I'm going to mid value to estimate. So 0 plus 4 divided by 2. So I'm going to estimate it to be 2 centimeter each. Okay, so some of you might be wondering, so do I include the 0 even though there's no equal sign? Yeah, for the mid value calculation, you just add up the first and the last number, then you divide by 2. Okay, so the 3 leaves, I'm going to expect it to be 2 centimeter each. So in a way, this will be the F and this will be the X. So I'm using 2 centimeter as the X. For the 9 leaf here, okay, what is the average? The average is 6. So I'm going to use 6 centimeter. Okay, so subsequently, you do the rest. We are using the mid value to estimate because we don't have the actual value. So in some exam question, they will ask you, why is this mean estimated? This mean is an estimated mean because the mid value of each category is used to estimate the actual length of the leaf. Okay, so bear in mind, why is this not accurate? Why is this only estimated? We do not have the actual value. We make use of the midpoint, in a way like a midpoint, to estimate the true value. So all these are my X. 2, 6, 10, 14, 18 are all my X. Okay, so I'm still using the table group data. So it's still the same formula. It's still the same formula like example 2, which also means that I need the same item. I need fx, I need fx, I need fx squared. So currently I know my fx, summation of f, 30 leaf. I don't know my fx yet, sum of fx. Okay. So if I want the sum of fx squared, I got to square all the x first. Okay, if you're worried, you forget, you square it first, then you multiply. So I will get 3 times 2 squared, 9 times 6 squared, 11 times 10 squared. So again, like I mentioned, you do not need to write down. But if you are worried that you make careless mistake, I suggest you write down. So you write down so that you don't punch wrongly. Sometimes you can punch wrongly. So in this case, it's quite a huge number. Sum of fx will be just no need to square, just multiply and add them up. 9 times 6. Okay, again, you might want to think, when you do a f times x and you are adding them up, do you know what are you getting? So you multiply the f and x, then you add them up, you actually get you 276. So do you know what is that 276? That 276, right, is actually the total length of 30 leaf in this context, but it's actually estimated. The total is estimated because I'm using the mid value to estimate each category. So again, let's apply the formula. So right now I got 276 and I got 3064. So apply the formula, you get the total length divided by 30. So that will give you the average length. So it's around 9.2 centimeter. Standard deviation, input your 3 item, 3064 over 30, 276 over 30 squared. So you just need to input and give your 3 SF answer. So in this case, I got 4.18 centimeter. So the 4.18 is the amount that can deviate from the mean. That means, right, I can expect a long leaf to be 9.2 plus 4.18, the deviation. So if it's smaller than the mean, maybe it can be as short as 9.2 minus 4.18. Okay, so this will be the few category that you actually need to know. Okay, but bear in mind, what is the kind of working you need to show? You will need to show this working. You need to show the individual value. So some teachers will make you write the formula. I think it's good that the teacher make you write the formula. So write the formula, input the item in the formula. So it must be shown. So if you want to be a bit more organized, you got to show the 3 items before you input the formula. That will be a bit more organized. Okay. You do not need to show the working. But like I say, if you are worried, you make calculator mistake. Okay, then you write it up. Okay, so in each case, right, you got to show the formula with the values input. So you cannot just give a 2.75. Where does your 2.75 come from? Okay, so you got to show the formula with the numbers input. Formula and the input numbers that you put inside the formula. So that's why I wrote what are the formulas to show. You need to show the 3 items and how the 3 items get input into the formula. Okay, single data and group data. Single data, there's only one case. Group data, there are 2 cases. The first case of the group data is the accurate group data. The second case is the not so accurate group data. Okay, so there are 3 practice questions that you can practice exactly the same idea in these 3 examples.